Did you know Docker can turn back time, allowing you to run software from over a decade ago with a single command? In today's tech dive, we're exploring the top 3 capabilities and how we think Docker revolutionizes software development, from resurrecting ancient OS versions to running legacy code without a hitch. We'll journey through these 3 capabilities, uncovering how it simplifies development, testing, and functions like a time machine in ways you never imagined. Stick around to discover Docker's most ingenious uses that could transform your development workflow and make you rethink what's possible with container technology. Before we dive into the top 3 capabilities, for the sake of the newbies to Docker, let's run a quick review of Docker and why it has been a game changer in the world of software development. Docker is a powerful platform that allows developers to create, deploy, and run applications in containers. Containers package up code and all its dependencies, so the application runs quickly and reliably from one computing environment to another. Think of it as a shipping container for code. It encapsulates everything the software needs to run, ensuring consistency across different machines and environments. This technology has been revolutionary for developers because it solves the age-old problem of, but it works on my machine. With Docker, you can make sure that if your application works in a container on your laptop, it will work on your colleague's machine in a test environment and in production without any surprises. Now onto the exciting part that you've been waiting for, the top 3 capabilities. Starting with the capability number 3, running legacy code with Docker. Imagine breathing new life into the oldest, most forgotten scripts with a tool that feels like magic. This isn't just about running software, it's about invoking the spirits of code long thought to have passed into the annals of history. Imagine, if you will, a classic Python 2 script crafted in the bygone era of the early 2000s. Its creators have since moved on, leaving it in the digital dust. Yet with Docker, this ancient relic can awaken, stretching and yawning into the bright light of the modern computing world, ready to run as smoothly on the latest hardware as it did on the old machines of yesteryear. The magic at the heart of this revival is Docker's init command, a spell so potent it can make these digital fossils dance to the rhythm of today's technological tunes. It's as if you've stepped into a time machine, whisking these programs forward into the present day, where they find new life, new purpose. This transformation is not merely about keeping old code on life support. It's a rejuvenation, a chance for applications developed in the past to find their place in the current digital ecosystem, free from the shackles of obsolescence. Let me share a real-life example to give you a better perspective. Back when I was working at a financial institution, we faced a dilemma that seemed insurmountable at the time. Our entire operation hinged on a Python 2 application. This wasn't just any piece of software. It was the heart of our daily operations, from customer transactions to back-end processes. But as the tech world marched towards Python 3, we found ourselves at a technological crossroads. The very thought of upgrading our core system to Python 3 was daunting. The risks involved and the potential for downtime were like navigating a minefield in the dark. We simply couldn't afford to disrupt our services. The stakes were too high. That's when Docker came into my life, almost like a stroke of fate. I took the lead on a project that would fundamentally change how we approached our software dilemma. We decided to containerize our critical Python 2 application using Docker. This decision was nothing short of revolutionary for us. By encapsulating our old, dependable software in Docker containers, we were able to run it seamlessly on contemporary hardware. This move was transformative, propelling us from a state of technological limbo into a position of strength and flexibility. The process of containerizing our application with Docker wasn't just about maintaining the status quo. It was about securing our future. It afforded us the luxury of time to meticulously plan and execute a gradual migration to Python 3. This wasn't a rushed or reckless transition, but a deliberate, strategic upgrade that minimized risk at every turn. By adopting Docker, we ensured uninterrupted operations, safeguarding the trust that our customers placed in us to manage their financial needs reliably. Now to our capability number 2, hosting a local stack with Docker. This will transform your local development environment into a symphony of efficiency and harmony, where every tool and service plays its part flawlessly. Docker Compose emerges as the orchestrator in the complex symphony of software development, transforming the management of services, networks, and volumes into a harmonious performance with a single configuration file. This simplification marks a revolutionary shift in how developers manage their environments, moving from a tangled process to seamless orchestration. Complementing this, Docker Compose Watch acts as the dynamic conductor, automatically refreshing the development environment in real time with each code change, ensuring the development stack remains in perfect sync with the evolving codebase. This duo of Docker Compose and Docker Compose Watch heralds a new era of development, where creativity is unleashed without the burdens of manual adjustments, making the development process more responsive, efficient, and enjoyable. Let's step back to the real-life example. In the financial institution that I was at, there was a web developer named Jordan. Jordan was embarking on the development of a complex application designed to enhance the institution's internal operations. This application was no ordinary project. It was a symphony of interdependent components, including a web server, a database, and a message queue, each playing a crucial role in the application's functionality. The challenge was formidable. Every change Jordan made to the codebase could potentially affect the delicate balance of the system. Traditional development methods would involve tedious cycles of stopping, updating, and restarting the entire stack to see the impact of even the smallest changes. It was a process that stifled creativity and slowed progress to a crawl. Had come Docker Compose, the tool that transformed Jordan's approach to building this application. With Docker Compose, Jordan could define the entire stack, web server, database, and message queue within a single comprehensive Docker Compose file. This file acted as a blueprint for the application's architecture, ensuring that each component could be spun up or down in unison, perfectly mirroring the production environment. But the real magic happened with Docker Compose Watch. As Jordan refined and evolved the application, making changes to the code, Docker Compose Watch worked quietly in the background, automatically updating the environment in response to Jordan's modifications. This was groundbreaking. It meant that Jordan could see the effects of code changes in real time, without the need to manually rebuild or restart the entire stack. This immediate feedback loop was revolutionary for Jordan. It slashed the time between development and testing, allowing for rapid iteration and experimentation. Bugs could be identified and addressed on the fly, and new features could be evaluated in the context of the full application, not just in isolation. Jordan's productivity soared, unencumbered by the previously cumbersome development cycles. Last but not least, our number one capability, using Docker as a time machine. Within the digital archives of Docker Hub lies a veritable Aladdin's cave, brimming not with gold and jewels, but with something far more precious to developers and historians of technology alike. A vast collection of historical software versions and operating systems, meticulously preserved since Docker's inception in 2014. This repository serves as a bridge across time, allowing modern developers to reach back and interact with the building blocks of today's digital world. Docker, in this context, is not merely a tool for the here and now, it's a time capsule, safeguarding the legacy of digital innovation for future generations. The ability of Docker to resurrect older versions of operating systems, such as Ubuntu from 2012, with the same ease as one might select a book from a shelf, is nothing short of sorcery. It's as if Docker has woven a spell of digital necromancy, breathing life into the software of yesteryear. This is not merely about nostalgia or the indulgence in technological archaeology. It's a critical functionality that addresses a pressing need in software development: backward compatibility testing. In a realm where progress is measured in lines of code, and the relentless march forward often leaves a trail of obsolescence in its wake, Docker stands as a guardian of the past, ensuring that no application is left behind, no matter how rapidly the sands of technology shift. To further illustrate this, let me tell you a story about a friend of mine, Alex, who worked in the embedded systems industry. Alex's company specialized in manufacturing single-board computers, the kind that power everything from DIY projects to complex industrial machines. Traditionally, their testing process was a marathon of inefficiency. For each type of board they produced, they had to create and burn a unique test image onto an SD card. This wasn't just time-consuming. It ate up resources like there was no tomorrow, not to mention the wear and tear on the SD cards themselves. But then, Alex had a eureka moment that would fundamentally change the way their company approached testing. He introduced Docker into their workflow. The idea was simple yet revolutionary. Instead of multiple SD card images, they would create a single, universal test image. This master image, when booted on any board, was designed to fetch the specific Docker image required to run tests for that board model. This new approach was like opening a window in a stuffy room. Suddenly, there was no need to juggle dozens of SD cards or spend hours burning new images. The time and resources they saved were substantial. More importantly, this method introduced a level of flexibility and scalability they had never experienced before. Testing different board types became a streamlined, almost effortless process. Alex's innovative use of Docker showcased not just its versatility as a tool, but also its potential to drive innovation in real-world applications. By simplifying their testing process, Docker didn't just save them time and money, it opened up new possibilities for efficiency and productivity that they hadn't even considered before. Now you can see how Docker transcends its role as a mere deployment tool, emerging as a multifaceted Swiss Army knife that redefines the boundaries of software development, testing, and security. From resurrecting legacy code to orchestrating development environments and fortifying application security, Docker proves to be an indispensable ally for developers navigating the complex tech landscape. And just when you thought you'd seen it all, remember the journey with Docker is only beginning. So, what's your Docker story? Share yours in the comments.